Welcome to Brain Vision.
Question here, the given is that the wavelength of the light lambda, which is equals to 585 nanometer, and this is equals to, we know nanometer is 10 to the power minus 9 meters. This will become 10 to the power minus 9 meter. And pulse duration is given that the time of the pulse duration t is equals to 450 microsecond, and this will become 450 micro means 10 to the power minus 6 second. And the specific heat capacity C, which is equals to 4190 joule per kg per Kelvin. And the heat of vaporization of water, we can say that C vaporization, which is equals to 2.256 into 10 to the power 6 joule per kg. This is the heat of vaporization which is given, and the amount of blood removed in each pulse is equals to mass m is equals to 2 macrogram, and we can write it as a 2 into macrogram means 10 to the power minus 6 gram, and in the kg will become 10 to the power minus 9 kg. And for the next given quantity, which is the starting current temperature T1, which is 33 degrees Celsius, and this will become 33 plus 273, which is equals to 306 Kelvin. And the final vaporization temperature T2, which is also given, which is equals to 100 degrees C, and this is equals to 373 Kelvin. And now for the first, we have to solve the first part, so we are solving here. This is the first part. So basically now we have to know that the energy must each pulse delivered to the blemish is given by q equals to mc delta t and plus mc vaporization. This is energy, and this will become mc into delta t. Delta t is t2 minus t1, and this will be same mc vaporization, and where m is the mass, and c is specific heat capacity of gas, and c vaporization is the heat of vaporization of water. So this basically become q here. This will become nothing but mass, which is given 2 into 10 to the power minus 9 into delta t, and delta t here is delta t, and delta t is 273 and 360. So this will basically become 373 minus 360 into C, which is given by, which is equals to 4190, and minus plus mass, which is equals to 2.256 into 10 to the power 6. So this basically become q here. This will become 5.1 after the calculation. This total part over here q will become 5.1 into 10 to the power minus 3 joule, and this basically become, when we convert into joule, so this will become 5.1 millijoule, because 10 to the power minus 3 is milli. So and now in the next part b, we have to calculate the power. So basically we know that the power p, power is equals to energy upon time, so or energy, which is q upon t. So this basically become, we have calculated 5.1 into 10 to the power minus 3 joule upon total time. Total time is given, which is equal to 450 microsecond, which is 10 to the power minus 6 seconds. So this basically become 11.33 watt. And for the next part C, which we have to calculate, as we know that the energy of a photon is E, which is equals to hc upon lambda. Hence, the number of photons emitted by each pulse that is delivered to the blemish will total energy delivered to the blemish by energy. So n in number of photon into energy of each photon is equals to q. So n will be q upon E. or rather we can say q upon hc into lambda. So after the value putting, this is q is 5.1 into 10 to the power minus 3 into lambda, which is 585 into 10 to the power minus 9 meter, and upon h is 6.626 into 10 to the power minus 34 into c is 3.3 into 10 to the power 8. We already know about the speed of light, so this basically n over here, this will comes out 1.5 into 10 to the power 16.